Hey everyone, it's Mrs. Fallon. I'm going to walk you guys through how to solve some log equations. I'm just going to go ahead and go through several different examples, and they should kind of match up with what you're going to be seeing in your practice. All right, let's take the first equation. What you'll notice here is this is natural log. It's just a special kind of log with a base of e. What you'll notice is that there's a natural log on both sides of your equation. Remember what your goal here is. Your goal when solving equations is to get your equations to balance. So ultimately, because these natural logs are on both sides, if we can get this 7x plus 4 to equal the 2x plus 11, then we can get those equations to balance. So really what we're kind of doing is like we're kind of canceling out those natural logs. So I'm going to do 7x plus 4 equals 2x plus 11, and then I'm just going to solve for x. So I'm going to subtract, and then I'm going to divide, and I get 7/5. You want to be careful with log equations because there can be extraneous solutions. So with a log, what you have to watch for is you can't take the log of 0 and you can't take the log of a negative number. So what I do is I check to make sure that if when I plug this x back into my original equation, I don't get like log or natural log of 0, not natural log or log of a negative. And if I plug 7/5 in, that's going to be a positive number. If I plug 7/5 in over here, it's going to give me a positive number. So what that means is that this equation is good. It's not extraneous. All right, I'm going to show you how to do this problem in two different ways. The one way of doing this is to just move this equation out of log form and into exponential form. So you might remember us doing this from before, just changing the format. So this becomes 2 to the 5th equals x minus 6. And then if you remember, 2 to the 5th is 32. And we get 32 equals x minus 6. So I get 38 equals x. Again, check for extraneous. It does not cause this to be 0 or negative. Therefore, this is a go. I want to show you one other way of doing this problem. And this is more of like if you had a little bit more complicated problems, it might be more helpful to kind of go this direction. I want you to think of it in terms of like how you would solve like taking inverse operations. So for example, if you had like x squared equals 49, you would square root both sides because the square root is the inverse operation of something that's being squared. Well, ultimately what we're doing here is the same thing. If I have a log with a base of 2, that's an operation. Remember, we're doing something to our problem, kind of like addition or subtraction or multiplying. So the inverse operation of a log with a base of 2 is an exponential with a base of 2. So I'm going to take 2 and I'm going to raise it to both sides of my equation. So it looks like this. So I have 2 raised to the left side of my equation. And remember, what you do to one side, you have to do to the other. So I have 2 raised to the right side. So again, all I'm really doing is making this and this now become my exponent with my exponential with a base of 2. Those would cancel out, and you will see I'll get the same thing as I had over here, and I'll get 38 as an answer. So there's just a couple ways you could approach problems like that. I don't really care which method you use. Again, there may be times in which one is more helpful than the other. Okay, let's try a couple others. These two are, if you notice, both of these equations have logs on one side, but not on the other. So just a constant on the other side. What you need to do here is use your properties of logs, like condensing logs. So remember, when you have two logs that are being added, again, the bases are the same because it's a log with a base of 10, even though it's not there, that's what it is, and a log with a base of 10. You multiply what you're taking the log of. So I'm going to condense this expression into log of 5x times x minus 1. Now you want to approach this either one of the two methods that I just talked about. So whether you think of it as putting this in exponential form or whether you think of it as just taking the inverse operation. So I'll do the inverse operation just because I want to reiterate that. So basically this is a log with a base of 10, so I need an exponential with a base of 10. So I'm going to do 10 raised to the left side, 10 raised to the right side. Whoops, I didn't mean to cross out the 5x. So I get 5x times x minus 1 equals 100. And so now all you're doing is solving this equation. So I get 5x squared minus 5x. I recognize that it's quadratic. Notice the x squared and the x. So I'm going to subtract 100 from both sides. And now I'm going to do my favorite thing in the world, which is factoring. I'm going to factor out a GCF first because it always makes life a little easier. And I'm going to keep factoring. So I get x, I get to factor into x minus 5, x plus 4. And then last, of course, if I solve it, I get x to equal positive 5, x to equal negative 4. Check both your answers. Make sure that neither of them or any of them cause an extraneous solution. So the 5 should be fine. This would give me a positive. This would give me a positive. The negative 4 will not. It would make both those logs negative. So we're going to cross that one out. And my only real solution here is x equals 5. Okay, let's try the next one. Same deal, as you notice. Different log, but the same process. So I'm going to go ahead and do it the same way. So I went ahead and condensed them first. I'll go then ahead and do this the exponential, or the, change it into exponential form. So this is 4 cubed equals x squared plus 12x, because I just distributed that x. So 4 cubed is 64. And you notice that it's quadratic. So I get that. So you can see here and try to factor this one. I've tried this, it doesn't work. So I'm gonna go ahead and use the Pythagorean theorem, the quadratic formula. So I'm gonna do negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm gonna grab my calculator. So I'm going to get negative 12 plus or minus, let's do the square root of, whoops, didn't need to do that. Okay, I'm going to do the square root of 144 minus 4 times 1 times negative 64, and I get 20. And so I get that to be over 2. So I'm going to continue on. So negative 12 plus 20 is 8. 8 over 2 is 4. And then the next one I get, so I get negative 12 minus 20, which is negative 32. Negative 32 over 2 is negative 16. So I think I was wrong. It does actually factor, but it's good to show you the quadratic formula anyway, because there will be a couple in your practice to actually, that will require you to use the quadratic formula. So good practice anyway. All right, anyways, let's check our answers. 4 can work because that would make my logs would be fine. Negative 16 will not. Don't get in the habit of thinking that just because it's negative, it's always going to be an extraneous solution. That's not necessarily always true. Just depends on what your equation looks like. All right, last but not least, we are going to do an inequality one. Notice that there's a less than symbol here. And then I want to show you a harder one, which is logs with have different bases. So give you a little bit of a challenge. Okay, number 6. You're going to solve this one the same way you did the ones that were just like equations. So the first thing I'm going to do is I'm going to subtract 9 from both sides. I just want to remind you that there's a rule with inequalities that if you multiply or divide both sides of your equation or inequality by a negative, you have to flip your symbol. So if you're getting the wrong answer on your practice assessment or practice problems, that might be why. All right, so this is log of x is less than negative 5. So this is a log with a base of 10. So I'm going to take 10 and raise it to both sides. And I get x is less than 10 to the negative 5. I'm just going to write that as, that my calculator. So I get it like 0.00001. So obviously a very small number. So a lot of people think that this is the only answer, like this is it. Now here's the reason I chose this one is because while this is correct, we have to add something else to this. Remember what we said about extraneous solutions. So there's multiple answers in this problem. And the multiple answers mean that the only answers that will work are any number that's less than 0.00001. That would make this equation true. But we also don't want like x to be a number that's 0 or negative, right? Because if we get x to be 0 or x to be negative, then that's going to provide an extraneous solution. So what I'm going to do is I'm going to add this disclaimer at the end, which is like, I just want x to be greater than 0. I don't want it to equal 0, I want it to be greater than 0. And the reason why is because if these are my solutions, if I had a number like -4 and I plugged it in here, that wouldn't hold true because I can't take the log of -4. So I just needed to add that extra piece on because I wanted to make sure that none of my answers gave me extraneous solutions. So although algebraically when I solved it, I only kind of got this piece, I had to look back at my problem and think, okay, are there any other restrictions that I needed to apply? And that was I needed x to be greater than 0. Okay, last but not least, you have a log on both sides of your equation, kind of like the first one we did. And the difference here is that the logs have different bases. So what I want you to do is I want you to start by taking the larger base and raising it to the left side and raising it to the right side. So I cheated here a little bit. I just, instead of rewriting it all, I'm just going to take 8 raised to this side, 8 raised to that side. So I looked at the larger base, and that's why I picked 8. And so what that does is those things would cancel out, and so I would get 4x. Now, on this side, 8 does not cancel out with log base 2, because in order for a log and an exponential to cancel, they have to have the same base. So we have to think about, we have to be a little creative here. We have to think, okay, well, how can I get 8 to be a base of 2? Well, glad you asked. That is 2 cubed. So 2 cubed is just another way of writing 8. And so we can write it like this. 2 cubed raised to the log base 2 of x. So we're going to continue to work on this left side of our equation for a little bit more. I got to get it into the right format. So now we're going to use our exponent properties. When we have a power to a power, so think like x squared to the 5th power, you would multiply them together. So this becomes 3 log base 2 of x. So 2 raised to the 3 log base 2 of x equals 4x. All right, still not done. We cannot cancel at this stage. And the reason why is there's this 3 here. So if you remember in one of the other previous videos about the properties of logs, one of the ways, this is an expanded form, we need to condense it. And so remember, when there's a number out in front, we can raise it back up. We can take, this is actually your exponent on whatever it is in this position. So in this case, x. So we're going to put that 3 back. So a lot of mistakes are is that people just start canceling the 2 in the log base 2 and get an answer of like 3x, and that's not true. So what this is going to look like is you're going to have 2 log base 2 of x cubed equals 4x. So notice, just brought that 3 back up. Now I can cancel. I have 2 here, an exponential with a base of 2 and a log with a base of 2. Those can cancel. So now I get x cubed equals 4x. This is a polynomial. We're good at polynomials, so we're going to go ahead and solve this. So I'm going to subtract 4x from both sides. We are not dividing by x. We have to think factoring. I'm going to factor out an x. So I get x times x squared minus 4. And if I solved that, I could keep factoring if I wanted. Remember, the x squared minus 4 could factor into x plus 2, x minus 2. Oops, it's supposed to be a 0. Okay, so now my solutions, it's a cubic, right? X cubed should have 3 solutions. X equals 0, that's from that one. X equals 2, and x equals -2. You have to check all 3. So go back to our original. If I plug in 0, I would get a log of 0. So that one doesn't work. If I plug in 2, that one's okay. If I plug in -2, that gives me a log with a negative number. Can't do it. So the only answer that works here is x equals 2. But this is definitely a little bit more complicated. I think there's one in your practice with that, but it's also, especially for honors, practice ones that you will see next year as well when you get into honors pre-calc. All right, if you have any questions, come join your teacher for office hours. Thanks, everyone.